The Robot Series, Season 1, Episode 3 Understanding Sensors, the eyes, ears, and nose of every robot. Hello innovators. Welcome back to the Robot Series, where we learn, build, and innovate. In our previous episode, we explored the basic electronic components like LEDs, resistors, and breadboards, the foundation of every circuit. Today, we are stepping into something even more exciting. Sensors are like the sense organs of your robots and devices. They help machines see, hear, feel, and respond just like living beings. In this episode, I'll introduce you to 8 of the most important sensors that every student in the field of electronics and robotics should know, along with how they work, the pins they have, and the voltage they used. Let's get started. Light-dependent resistor, LDR sensor. Our first sensor is the LDR, or light-dependent resistor. This sensor detects the amount of light in the environment. When light falls on it, its resistance decreases. In darkness, its resistance increases. That's how it knows when it's bright or dark. It has 2 pins, one connected to signal and the other to ground. It works with 5 volts or 3.3 volts, depending on your circuit. Example, when you build an automatic street light that turns ON at night and OFF during the day, that's the LDR in action. Applications. You'll find it in automatic lamps, light meters, solar projects, and even smart windows. Ultrasonic Sensor, HCSR04. Next up is the ultrasonic sensor, also known as the HCSR04. This sensor measures distance using sound waves, just like how bats use echolocation to see in the dark. It has 4 pins, VCC for power, GND for ground, trig to send out sound pulses, and echo to receive the reflected sound. It operates at 5 volts. The sensor sends out a high-frequency sound wave through the trig pin. When it hits an object, it bounces back to the echo pin. The sensor calculates the distance using the time taken for the echo to return. It can measure between 2 centimeters and 400 centimeters, with about 3 millimeters accuracy. Example, when your robot avoids a wall or object, the ultrasonic sensor makes that possible. Applications. You'll see it in robot cars, parking systems, and water level monitors. Infrared sensor, IR sensor. Our third sensor is the infrared sensor, commonly called the IR sensor. This one detects objects using infrared light. It has 3 pins, VCC, GND, and out for output. It operates at 5 volts. Here's how it works. The IR LED emits infrared light, and if something is in front of it, the light bounces back to the photodiode. The sensor detects that reflection and outputs a high signal. Example, if your line-following robot stays on a black track or detects a white background, it's using IR sensors. Applications, line-following robots, motion detectors, obstacle counters, and automatic doors. Temperature and humidity sensor, DHT11, DHT22. Next, we have the DHT11 and DHT22 sensors, used to measure temperature and humidity. These sensors are perfect for weather-based and environmental monitoring systems. They have 3 pins, VCC, GND, and data. They operate at 5 volts inside the sensor. A thermistor measures temperature, while a capacitive humidity sensor measures moisture in the air. The DHT11 works in the range of 0 to 50 degrees Celsius and 20 to 80% humidity, while the DHT22 has a wider and more accurate range, -40 to 80 degrees Celsius and 0 to 100% humidity. Example, a smart greenhouse that turns on a fan when it's hot, that's controlled by a DHT sensor. Applications, weather stations, home automation, smart farming, and HVAC systems. PIR sensor, passive infrared sensor. Next is the PIR sensor, short for passive infrared. It detects motion by sensing infrared radiation from warm objects like humans or animals. It has 3 pins, VCC, GND, and out. It operates at 5 volts. The PIR sensor has 2 slots inside made of special material that detects infrared light. When a warm body moves in front of it, the difference between the 2 slots changes, signaling movement. It can detect motion up to 20 feet away, with a detection angle of about 110 degrees. Example, motion lights that turn ON when someone walks in front of them use a PIR sensor. Applications, security alarms, automatic lights, smart doors, and robots that detect humans. Gas sensor, MQ series. Number 6 is the gas sensor, specifically the MQ series like MQ2, MQ3, and MQ7. These sensors detect gases such as methane, carbon monoxide, or smoke. They have 4 pins, VCC, GND, DO for digital output, and AO for analog output. They operate at 5 volts. The sensor contains a metal oxide semiconductor that reacts with gases. When gas molecules come into contact with the sensor surface, the resistance changes, producing a measurable signal. Example, the MQ2 detects LPG, propane, and smoke, perfect for gas leak alarms applications, smart kitchens, air quality monitoring, and fire safety systems. Sound sensor. Microphone module. Our 7th sensor is the sound sensor, which detects sound vibrations in the AIR.IT. Has 3 pins, VCC, GND, and out. It operates at 5 volts inside the sensor. There's a microphone that converts sound waves into electrical signals. When the sound intensity exceeds a certain level, the sensor outputs a high signal. Example, a clap switch that turns on your lamp when you clap. That's done with a sound sensor. Applications, voice-controlled systems, sound-activated robots, and noise detection alarms. Temperature sensor, LM35. Finally, let's talk about the LM35 temperature sensor, one of the most accurate analog temperature sensors available. IT has 3 pins, VCC, GND, and out. It operates at 5 volts. The LM35 outputs 10 millivolts per degree Celsius. That means if the temperature is 25 degrees Celsius, the sensor outputs 250 millivolts. It's linear, accurate, and easy to use with any Arduino or microcontroller. Example, if your cooling system turns on a fan when the temperature rises, the LM35 is the brain behind it. Applications, thermostats, industrial monitoring systems, and environmental controls. And that's a wrap on today's episode, the 8 most important sensors that every student, hobbyist, and engineer should know, from detecting light, sound, temperature, and gases to sensing motion and distance. These sensors form the foundation of modern robotics and IoT systems. In our next episode, we'll explore how to connect these sensors to the Arduino and get real-time readings on an LCD display. So make sure to subscribe, like, and hit the notification bell.